Hi Pre-Calc students, this is going to be a quick review of 4.3. This is an extra Illuminate, totally optional, and it's going to cover some of your quiz questions. I went by the quiz this time because I didn't receive any questions about the checkup, and it's going to be on an identities application, so applying what we know using our identities formulas. So again, you're going to receive 5 points of extra credit for this session. What I'm going to ask you to do is, I believe there are actually 6 examples. Keep track of your answers to all 6 examples. One of them will be the key to you earning the 5 points of extra credit. So I'll tell you which one that is later on. So for now, just make sure you number your problems 1 through 6, and as we're going through the answers, circle your answers, and one of those will earn you your 5 points of extra credit. Let me quickly stop and share this file with you in case you would like to stop and print it out. So let me add this for you guys. I know some of you prefer to write right on top of it, and that works for me. So whatever works for you works for me. So if you want to stop and print off this quiz review, then you can write right on top of it with me. So that would be just fine. All right, so number 1, it's going to ask us to solve this equation right here. And again, these are not exactly your quiz questions. I might have changed the numbers here or there, but all of the steps would be exactly the same. So when we see this problem, and I can see that it's the cosine, so cosine means I'm going to be using this formula right over here, and it's a subtraction. So if it's a subtraction, that means when I go through and I'm using my formula, I have to use the bottom. We kind of talked about this in our last recording. But the formulas are written like this just to save space. So if you have to go u minus v, that means you're using the bottom portion of the formula. So let's go ahead and write out what we have. So I would have cosine of 5 pi over 3 times cosine x. Now again, since I'm using the bottom, I'm going to be using that plus sign. Sine 5 pi over 3 times sine x. So that would give us option C. Okay, from here, I would continue to solve or simplify if this was not my final answer that they were asking me for. I can look up what sine 5 pi over 3 and what cosine 5 pi over 3 is on our identities chart. I guess I didn't give you a picture of it, but it's on that identities formula sheet where we can look up what each of those answers is. So cosine 5 pi over 3 is a 1/2, and sine 5 pi over 3 is a negative root 3 over 2. So then we ask ourselves, is there anything else I can do to simplify this? So I'm looking for anything that I could add together. Nope, can't add a sine and a cosine. So then I'm asking myself, is there anything I can pull out in front to simplify? Here's a 1/2, here's a negative root 3 over 2. So since they both have a divide by 2, I can certainly pull that out in front as a 1/2. And that would be your final answer. So I pulled out the 1/2, and that is as simplified as this problem gets. So my answer again would have been right here. This just asks for that next step, which we already did on the last page. Okay, next kind of problem would be if they ask you to solve this. This is a great one to write down because you are definitely going to have one like this on the quiz. They're going to ask you to solve. So they want to know in what spot on the graph, when I multiply sine x times cosine x, am I going to get a value of negative root 3 over 4? So immediately you should be thinking to yourself, well, it's a sine times cosine, so I know I'm going to be using my product to sum formula, and my sine slash cosine is right here. So I'm going to have a 1/2 sine x plus x, I guess I should write like that, plus a sine x minus x. And all of this is going to equal that negative root 3 over 4. So I'm basically just replacing this left-hand side with my product to sum formula. So from here, let's continue on down and simplify. So I'm going to get 1/2 sine of 2x plus sine of x minus x is sine of 0. What is sine of 0? 0. So I can just cross that off. That part totally goes away, which is pretty handy. Okay, so let me rewrite what I have left over right now. So I have negative root 3 over 4 equals 1/2 sine of 2x. Okay, again, my whole goal is to know what x is, so I'm going to get rid of that 1/2 by multiplying by the reciprocal. Whatever you do to one side, do to the other side. So the 2 and the 4 are going to reduce to give me negative root 3 over 2. Then on the right side, I'm left with sine of 2x. Okay, for now, what I want you to think about is this is 2 times what a normal sine would be. So let's just say I have sine of theta equals negative root 3 over 2. And then over here on the side, we'll say that theta equals 2x. There's a reason that I'm doing this, and I'll show you why in just a second. So again, all I did was I replaced my 2x with the theta, and I want us to look at our chart, and let's find all of the spots where our sine value gives us a negative root 3 over 2. Did I give us a picture? I did not. I thought I put one in here somewhere. I guess I didn't. Sorry. So look at your chart and look for the spots where you get a sine that equals negative root 3 over 2. You should find 2 spots. You should find that it's at 4 pi over 3 and at pi. And we're going to say pi plus n because, again, remember, for every half rotation, you're going to get that same value. So here's where, so all we did to find this value was we looked on our chart, and we found that our chart gives us this. Now we're going to substitute that our theta equaled 2x. So here's what our theta was. Now I'm going to say that my 2x equaled that. 4 pi over 3 plus pi n. So all I have to do is solve for x and then I'm done. So originally I had 2 times my sine. So how am I going to get rid of the 2 down here? I have to divide by 2. So I'm going to divide both sides by 2 and I'm going to have my final answer. Because I couldn't do that before because this is a particular spot on my graph. So I was finding the exact spots where my sine gave me that value. Now that I know all of the spots where those solutions are, I have to resubstitute in that my theta was actually 2 times my original value. And to get rid of the 2, I'm going to divide by 2. So let me give myself some space up top here. So here's where I'm at. I'm at 2x equals 4 pi over 3 plus every pi n. And I'm going to divide both of these by 2. Remember, dividing by 2 is the same as multiplying by 1/2. So 4/3 times 1/2 would give me 4/6. And this would give me pi over 2. Okay. So let's reduce that one last time. So those would be where all of my solutions are. So review that if it didn't quite make sense. You should be good up until this point. At this point, we just forgot that it was, well, we kind of set it aside that it was a 2x, solved like I did for a regular sine, found those 2 spots, and then I re-solved with the 2. So to get rid of the 2, I divided by 2. Divide both sides by 2 up here, and then you get your final solutions. So you will have one of those on the quiz. When things are multiplied, go to your product formula, simplify as much as possible, and you guys will be just fine. So that was number 2. Number 3 asks us to simplify using identities. So I kind of already have, I'm showing you the first step here. So here's your original problem. Notice there's not 2 sides of the identity this time. There's only one side. So they're telling me which side to start with because they didn't even give me 2 sides. So the first thing I'm going to do is I'm going to multiply this through so I can get rid of my parentheses. So I'm doing tan x sine x times cosine squared x cosecant x, and then tan x sine x times a negative sine x. So it kind of looks kind of messy, but it's not really hard. It's just, you just need to keep track of your stuff really, really well. From here, let's replace what we know cosecant to be. So I'm going to have tan x sine x cosine squared x. Cosecant is the same as 1 over sine. And on this side, let's simplify sine x to say sine squared x. So on the left, do we see anything that I can simplify a little bit further on your left-hand side? You should be saying a sine x times 1 over sine x will go away. So on the left, I have tan x cosine squared x. And on the right, I'm having tan sine squared x. Now, if we're going to simplify this a little bit further, if I'm looking at both portions of my problem, they both have a tan. Oops, that should be a tan x. I can factor that out in front. And now I have cosine squared x minus sine squared x. Now I'm thinking, I bet one of these is an identity. So let's look on our trig identity sheet. And I'm looking at my section that's called the double angle formula or double angle identity. And this is one of those double angle identities. Cosine squared x minus sine squared x is the same as cosine 2x. And again, this was our double angle identity. And that's as simplified as it goes. That would be one of your answer choices on a quiz or a test. Okay, so review everything that I did on this slide and let me know if there was something that didn't quite make sense. You can always email me, call me, whatever you need to do. I'm here to help you. Okay, that was number 3. Now our next 2 are going to focus on our half angle formula. So let's do a simplified version first. Oh, I thought I inserted a new slide here. Oh, that's a bummer. I didn't upload my saved slide. Okay, let's do one over here that's called 3A. Because I want to do an easier version first before I do the harder version. So can you guys stick with me for a second? This one will be called 3A, over here on the right. And my problem is going to be 1/2 times 1 plus cosine 16. Okay, so we're working on 3A right now since my PowerPoint did not save my more recent example. And what we're going to do is we're going to rewrite it using our half angle formulas down here at the bottom of the page. So this is telling me that cosine squared theta, theta is the same as x, equals 1/2 1 plus cosine 2x. So here's my question. If I'm looking straight up above, what's my x going to be? So the 1/2's there, the 1's there, the cosine's there. Oh, but I don't have an x, I have a 2 times x. So this section is really the same as 16. Is everybody okay with that, I hope? So 2x is the same as 16. So my question to you guys is, what's x? So we're asking ourselves, 2 times what number is 16? So we would say 2 times 8 is 16. So my x is an 8. So when I need the 8, I need to add that to know what to fill in on the other side. So cosine squared 8. So hopefully that makes sense how I got that. They gave us the right-hand side of the problem right here. They wanted to know what's the left-hand side of the problem. Okay, we're going to take that same idea now and we're going to move on to number 4, which is just a little bit trickier than number 3. Okay, so for number 4, Again, we know that we want this to equal cosine squared theta. Ooh, it's supposed to have a 1/2 there, but it doesn't have one. We'll talk about that in a minute. 1 plus cosine 2 theta. So, what's theta? If my cosine here is 8x, and our formula says it's 2 times theta, 2 times what is going to give me the 8? What do you guys think? What's this really going to be? So 2 times 4x. So 2 times 4x is going to give me 8x. 2 times 4x is going to give me 8x. So when I'm looking at what theta is, to plug it in on this side, I know that I have to plug in a 4x in this case. So cosine squared 4x equals 1/2, 1 plus cosine 2 times 4x. Here's the deal though. The original didn't have a 1/2, and I do need to have a 1/2. So in order to make this side have a 1/2, what are you going to have to do? What are you going to have to do to both sides? Because the original didn't have anything, right? So how can you make, if the formula is supposed to have a 1/2, but now it's just showing up as nothing. Remember, nothing is really like having a 1 there. What am I going to have to multiply this by if I were to want to have a 1 there? So if there's a 1/2 in the formula, but they don't have a 1/2 up here, how do I make a 1/2 become a 1? I have to multiply both sides by something. To multiply both sides by 2. If you multiply by 2, it makes the whole thing go away. So I'm going to get 2 cosine squared 4x. That's what they're looking for. 2 cosine squared 4x. That's your answer for number 4. So here's kind of how I rethink it one more time. So at the beginning, I know that this is really a 2 theta in there. So I'm asking myself, 2 times what gives me the 8x? 2 times 4x gives me the 8x. So I got my 4x right away. I know that this side's supposed to have a 1/2, but it doesn't have a 1/2. So to make a 1/2 appear, but not really, like be disappeared to have a 1 there, you have to multiply by the opposite or the reciprocal, which is a 2. So multiply both sides by 2. It kind of makes sense if you come back to the bottom equation right here. If I want to make this bottom equation look like this one, if I multiply both sides by 2, now that looks like what I had to start with up here, right? On the right-hand side, it was just a 1 plus a cosine 2 theta, 1 plus a cosine 2 theta. So how did I make this one look like that one? I had to multiply both sides by the 2. That's how I got rid of that 1/2 out front. So that's the other way to think about it. So that's your answer for number 4. Okay, number 5 says, how many solutions does the equation cosine 6x equal 1/2 have on the interval 0 to 2 pi? So this time it's actually giving me a specific interval. It's not saying how many solutions does this have forever, where we would keep adding our 2 pi or our pi over and over and over again around the circle. This time it's giving me a specific interval. So a couple things you could do. You could graph this, because for me, I'm a visual person and I would like to see the graph. In order to graph that, not that they have you doing a lot of graphing this unit, but I'm a visual person, so sometimes it makes more sense. If you multiply both sides by 2, you get 2 cosine 6x. If you were going to graph that thing, it's like this, like up and down, up and down, up and down, up and down. Remember what the word solution means. Solution means how many times does it cross the x-axis. So you could count those spaces. The answer is actually 12. Or what else you could do, there's a kind of a cool trick here. If you take your denominator and you multiply it by your x, that's how many solutions it has. It doesn't always work like this, but this unit it does. So for now I can teach you that shortcut. The real way, again, I would love for you to be able to graphically see where it's crossing. But again, the shortcut method is just to get rid of the 2, multiplying by the 2. So you would get 12. So I could throw any number in there. I could say sine of 5x equals 1/3. 3 times the 5, it would have 15 solutions. And again, you could check that graphically, but I'm just showing you that that does work for right now when we're just asking for a single period, basically. Okay, then the last problem I want to go over is on projective motion. See, I removed all this stuff. I didn't save my changes. Okay, so on a projective equation, if I'm telling you that here is this is the only kind on projective motion, by the way. They don't even give you numbers to plug in. They're just going to give you the formula that looks like this. Okay, now in the online lesson, they give you a secondary equation, and I also would like this secondary equation in your notes. Whoops. That should be a 2. Here, let's just start over. Okay, I want to know, why are those the same? Are you able to explain that to me? Why are those 2 the same? What did they do? Think about it for just a minute. Okay, so this is the same as down here. Down here, they talk a lot about G, which is your gravitational pull, when we're talking about real-world applications here. So if I put a 32 on the bottom, then they just pulled out a 2 there. Think about what the 2 really means. The 2 is the same as the 2 being on top. So that's just 2 over 32 reduces to 1 over 16. That's why they're the same. So I just want you to have in your notes that these 2 formulas are the same. Yes, they are. Because you might have a true or false question about if they're the same or if they're not the same. So yes, they're the same, because here they just pulled out a 2. Here it's just the reduced version. V sub 0 is just your initial velocity, but again, on the quiz they don't even ask you to solve one of these, they just are asking you a true-false question about the equation. Okay, so I know that was just a quick review of 4.3. It was not the checkup because none of you guys ended up sending me questions to include in the slides, so I just went over a quick quiz review. If you start working through the checkup and you still have questions, please let me know. So to earn extra credit for this 4.3 session, please type your answer to problem number 4 into the 4.3 drop box, and you're going to earn 5 points. So yay, this was extra, but it will boost your grade, and hopefully it will help you do better on your 4.3 quiz. Thanks guys, have a great day.